Alright, so I've taken a look at the feedback that you guys have given in terms of what types of questions you'd like to go through. And what I saw was a lot of simultaneous equations and graphing questions. So I've put together a selection of graphing and simultaneous equations, and I'm going to go through some examples with you. What I'll also do is, if you want to come see me and get a copy of these questions for you to do on your own, that's absolutely fine with me. So for this question, it's asking us to sketch a draw a graph of y equals x squared minus 3x plus 1 for values of x between minus 2 and 4. So first thing that you're going to get any sorts of points for is to make yourself a table of values. So to do that, we're just going to set up our table of values for our different points. Okay, so when I do that, I'm going to look at my first one, which is minus 2. So I just have to clear that off. So if we look, we've got minus 2. So when I look at minus 2, first thing I'm going to need to do is minus 2 squared. So minus 2 squared is going to give me a positive, okay, it's going to give me a positive 4. Then from there, I'm going to go back to my question, x squared minus 3x plus 1. So from there, I need to do minus 3 times minus 2, which gives me a positive 6. So that gets me up to 10 plus 1 gives me 11. So I'm going to make a list over to the side here of my, x, y values. So minus 2, we have positive 11. So for minus 1, we're going to have positive 1. Minus 3 times minus 1 gives us a plus 3. So plus 1 plus 3 gives us 4. Plus 1 again gives us 5. 0, we're going to have a plus 1. 1, we're going to have 1 squared minus 3. So 1 minus 3 gives us minus 2 plus 1 gives us minus 1. 2, we're going to have 4 minus 3. So we've got 4 minus 6 gives us a minus 2 plus 1 gives us minus 1 again. So this is when our graph is, so in between 1 and 2 is going to be my vertex. Then we've got 3. So that means that 3 is going to be 1. So remember that when you have a parabola, it's going to be parallel, or it's going to be symmetrical on both sides. So we double check that though, because we've got 3 squared is 9. Minus 3 times 3 gives us 9 again, so that gets us 0. Plus 1 gives us 1. And then 4. We are going to have 4 squared is 16, minus 12 gives us 4, plus 1 gives us 5. So again, you can see that this is going to be my vertex, my turning point, okay? And I've got some symmetry on both sides, okay? So next thing I'm going to do is I'm just going to plot those values. So I'm actually going to split my screen here so that I've got my table of values on one side so you can see it. Oh. Apparently I've made it angry. So that's fine. Anyway, we're just going to do the best we can here. So we've got minus 2, 11. So I'm going to go minus 2 up to 11. Okay. Minus 1 is at 5. 0, 0, we are at plus 1. 1, we're at minus 1. 2, we are also at -1. 3, we go up to +1. And 4, we are at 5. Now, to make our graph even more accurate, what we can do is we can look at a value of 1.5, because that's going to be equidistance between those points. So, if I look at that, I'm going to have, I'm going to go down here, sorry. So, I'm going to have 3/2 squared gives me 9/4 minus 3 times 3/2 gives me 9/2, so that's going to be 18/4, so I'm at minus 9/4. Minus 9/4 plus 4/4 leaves me with an answer of minus 5/4. So 1.25, basically. So what I can do there is I can plot my point here at 1.25. So if I look, I've got 1, 2, 3, 4, 5, which means that I'm going to go down 1 and a bit. Again, it's a little bit difficult to do on a computer, but you just do the best you can. Okay, and again, a little bit difficult to do on a computer, but you do the best you can, and there you have your line. So again, first step is just to draw yourself a table of values. Okay? Alright, I'm going to leave that there as our first example.